Welcome back to Hex and Cube map generation visual scripting using uNode Part 6 and final episode. In this Part 6, we will connect the tiles with line geometry starting from a random location. Alright, we're going to go ahead and start in the game tiles start method, and we're going to remove the auto start component. We won't be needing that. And then we will also remove the ifs down here with the auto run. We won't be needing that either. We'll go ahead and get rid of the show geometry for now. We'll be adding that back in a little while in a different area. Alright, now that we've kind of cleaned that up, we will add three additional new functions. One called initialize node, one's going to called initialize neighbor, and one will be initialize neighbor routine or delay, your choice. So here we go. Click the button, the plus button 3 times. We'll get them in there, and then go ahead and name them. For the initialize neighbor routine, it will be a IEnumerator, so we need to change the return type in the top right hand corner to IEnumerator. Alright, well, now that we're in the IEnumerator, we might as well actually start there, and we'll kind of finish this up. So the first item we're going to do is wait 4 seconds, and we'll drag that in. We'll change that to 0.05. That's probably a good initial value. Then what we're going to do is get a for each loop. So right click on the canvas or drag and drop from the pin of the wait and drag the for each loop in. We will want to be calling the initialize nodes, but in this particular case, the initialized node doesn't have a input parameter, so we need to remove it, go back over to the initialized node, and add the parameter here. It's going to be game tile of type game tiles. So go ahead and get that set up correctly. There we go. Now it's listed as a parameter. We should be able to drop that into the IEnumerator as a function, and it will have an input value. Go ahead and link the body of the for each loop to that game tiles. Or initialize nodes, sorry. And then what we're going to do is grab the M neighbor tiles and put that as an input value of the for each loop. The output pin of the for each loop, or the value pin, will be a game object.get component of game tiles, and that will feed into the initialize node of type game tiles. Now go ahead and go into the initialize node function and drop in an if statement. Here, this will be actually a fairly short function. What we're going to do is do if true equals show geometry, initialize neighbor, and then we'll set is initialized to true. So we'll need to add is initialized as a boolean into the variables area. So I'll go ahead and create a new boolean and call it is initialized. There we go. Alright, now we got it moved all the way to top. We're going to use that is initialized as the input to the if statement as well. So if is initialized is not true or not, then we're going to go ahead and run this show geometry initialize neighbors, and then at the end of that we will say initialized is now true, because that will be for the tile itself, so it has been initialized. Here's a another pretty straightforward and short function. Initialize neighbor is really going to start the coroutine of the initialize neighbor routine of this. So that's really all there is to it. Now we're going to go ahead and transition over to the game manager. So if you don't have that open, go ahead and click it on the hierarchy and open in the uNode editor. And we're going to add a new function in here. This will be get tile list. Alright, in the getTileList function, we will add a for each loop. So go ahead and drag that pin down and find the for each loop. Then we're going to go ahead and add a this, and it'll be this component transform. So make sure you select the transform from the inherited member list. So select the get component in children with the T for temp. Then you should be able to define game tiles as a secondary option. There, that one, and that one, and then select, and link that into the for each loop. So from the body of the, or the pin of the for each loop, the body of pin of the for each loop, we're going to do a list.add of game objects of the tiles. So we'll need to drag in the tiles variable. Then we'll go ahead and find the list.add, and then we'll take the value from the for each loop, and that'll be a component.gameObject, and we'll link those together. We're going to go ahead and create a local variable called child count. This will keep track of the children, or the number of items that we add to the list. So we can go ahead and click on the plus of the local variables, call this child count, and then what we're going to do is drag that in and set that, and child count plus child count plus 1 equals child count. Once we've added that, we're going to go ahead and add a new function or method. This function will be called getStartTile, and this will define where we start to draw the geometry from. So it'll be a random, we'll use the random range in this particular case to find that location. Once the getStartTile is created, go back to the getTileList, and from the for each loop of the next pin, drag in the getStartTile, and we'll launch that function after this for loop is finished. Also note that the add node was a float node and not an integer, so we wanted to swap that addition out with an integer type of addition. Okay, we're going to go ahead and go back to the getStartTile and finish that function out, but we will need an additional variable, a global variable called StartTile. This will be the tile that we start the geometry with. So go ahead and it'll be of type gameObject. So go ahead and call this StartTile. First thing we're going to do in the getStartTiles function is we will set the start tile equals tiles of a random range between 0 and tile.count. So we'll go ahead and drag in the tiles variable, and we'll drag the tiles into the list.getItem. We're going to need to get the item from the list. So we will do a random range, basically using the list.count, get the random range of that, and then pull that item out of the list and set the start tile to that. Looks like I did this a little bit backwards, but we'll go ahead and get the auto run component working first. So we're going to drag in the start tile, get component of game tiles, and then we're going to set the auto run of that to true. And this will replace what we had removed at the beginning of this video around the auto starting. This will auto start the first tile. In this particular case, we will need to add a boolean to the second pin of the set value so that it is true or is check marked. Alright, now we'll go back up to the get item and set up the random range of the list. So we'll need the tiles variable again. We will get the list.count from that. Then we will do the random.range. And if you notice when I select the random.range that there are two of them. There is both a float random range and an integer random range. In this particular case, you're going to want to select not the float one like this, but you'll want to go ahead and select the int random range instead. Basically, we are setting the random range from 0 to the count of the list itself. Alright, that finishes up the get start tile function. That one is completely done. So let's bounce over to the get tiles script, and we're going to go over to the time delay enumerator and add an additional couple of lines of code here, or a couple of nodes. In this particular case, it's going to be an if statement and auto run. And then what we'll want to do is do the initialized node here, and this goes into the initialized node of game tiles, which is the function. Let's go ahead and bounce back over to the game manager script and the create grids function. We are going to, instead of doing the entire pink section, we will just call the get tile list. Basically, the get tile list function is replacing everything that we had in the highlighted region, the pink highlighted region. Okay, once we've done that, we're going to go ahead and bounce back over to the game tiles script, and we're going to go into the initialize neighbors routine, or neighbor routine enumerator, and we're going to modify this a little bit. So what we're going to do is, we won't need this initialize node anymore. We will be calling game tiles.initialize node. We'll go ahead and drag the object or value from the for each loop into the instance of the initialized node and convert if possible. We'll then go ahead and delete the two nodes that we no longer need. And then we'll go ahead and compile it, and then we'll go ahead and see if this does in fact initialize the nodes for us. It should at least kind of start that process. Alright, this wasn't restarting or wasn't starting the nodes properly, and it worked the first time I pushed play, but did not actually work the second time I pushed play. So under the project settings, under the editor, if you go down to enter play mode settings and uncheck enter play mode options, that I noticed was caching some of the information and was causing this not to work properly. If you have that selected, you will need to have go and uncheck that. The initial reason I had that unchecked is to make the, when you click play, to actually make it go faster instead of reloading like that every single time. There were some advantages of actually having that check mark, because it made the clicking play in the editor go a lot faster, but the downside is that it did cache information and get different results depending on when you pushed play and if you push play again. We also will want to go into each of the prefabs and uncheck the auto run option here. It needs to be unchecked, and we'll want to do that on all three of the game tiles or prefabs. Alright, now we're going to go ahead and create a new script called tile linker. So right click in the hierarchy and go to uNode and select C# component. And in this particular case, we do want to fill out the namespace. Make sure it's inherited from mono behavior. And then go ahead and create and then save that. And we're going to call this one tile linker. Once that object is in the hierarchy, go ahead and open it with the uNode editor. Make sure that the name tile linker is in the top right hand corner under name. Feel free to add a summary as you so desire. And then what we're going to do is we're going to add a few variables and one function. So the first variable we're going to do is border width, and that'll be a float. And then we'll go ahead and do a line width, that will also be a float. And then we're going to do a scale time, and that will also be a float. We're also going to go ahead and do a lean tween ease type, so we can call this one lean LT ween ease type. The function we're going to create is going to call draw link. That is going to be of type void on the return type. It will have two input parameters. One input parameter will be a start position, and the other one is going to be the end position, both of which will be vector 3s. And for the lean tween ease type default, you can select whatever ease type you want. For the scale time, 0.05, for the line width, 0.3, and for the border width, 0.02 seem all good default values. Alright, we'll go ahead and get cracking on the draw link function now. We will need three local variables for this function. One is going to be called dir vector, and that'll be a vector 3. Then we'll have a float, which will be called z-scale, and then we'll have a new scale, which will also be a vector 3. So we'll need a vector 3, a float, and a vector 3. Call them what you want. Let's start by right-clicking on the canvas and go Add Node Set, and we will look for transform.localScale. We will set that, and then we will get the transform component, or component.transform, which is in the inherited member list, and it'll be this.transform.transform.localScale. Then what we're going to do is feed the second node of the set value of a new vector 3 with all three float values available. And then we will set the line width to the x value of that vector 3. Once that's all linked up, we'll go ahead and change the y value there to 1. Now we're going to go ahead and set the local variable dir vector to the end position minus the start position. So go ahead and right click on the canvas and add node set, or go ahead and drag in the dir vector and click set. We will want to get the new vector, I'm sorry, a subtraction. There we go. And then we will get the end position, end pause, and start pause. Right click on the canvas, select add node, type in start pause or end pause. There we go, got them both. And then we'll feed that directly into the subtraction, and you can just click continue if you get the warning box. That does change the output to a vector 3, so we can feed that directly into the set value. Next, we're going to go ahead and set the z-scale. So go ahead and drag and drop the local variable z-scale onto the canvas and select set. We're going to set that to the direction vector, the vector 3.magnitude minus the border width. We also will want to set the new scale, so if you want, you can drag that in and click set as well. We'll get that prepared. But nevertheless, we will get the direction vector and then the vector 3.magnitude minus the border width. Great. Now once all that's hooked up, we'll go ahead and set the new scale. We already dragged in the set value for the new scale, and that will be a new vector 3 with all three float options available. And then that will be the line width going into the x value and the z-scale going into the z value. And we will hard set the y value to 1.7. This will basically set what we want the scale to be over time. So this will be the new scale that we will want the game object to be, the linker game object to be. Go ahead and right click on the canvas and select add node set, and we're going to look for transform.rotation. We are going to set this object's rotation to the direction vector and we'll use the quaternion.look rotation. So we will need to grab the transform.rotation, and we will this and then drag it into transform.rotation and go ahead and convert that if possible. That's probably why I'm getting an error message. Nevertheless, then the quaternion pin for that set value will need to be dir vector, the local variable, and then we'll grab the look rotation. Not that one. We need to grab the one that has the vector 3 output. Let's see if we can find the right one. There we are. That looks better. Alright, let's get rid of that guy. This is one reason why I have kind of the code open, so I can kind of see what's going on in code while I actually work on the nodes. In this particular case, something looks wonky with the code, and so I'm going to go ahead and delete the this, and then actually have it convert if possible, and that seemed to fix the issue. Now we're going to go ahead and do add node set again. In this particular case, we're going to do this transform.position equals start position plus transform.forward multiplied by the border width. So we will get the transform position set value. And we'll need to pull in a couple of mathematical operations, both a plus and a multiply. So we'll go ahead and grab those right now. And then what we will do is this dot transform dot forward multiplied by border width plus start position. And don't forget to finish off that transform.position node there. We need to add the this to the instance pin and go ahead and convert that. So the last line of code for this function is the ease type, and we're going to do a leantween.scale. So we're going to go ahead and grab the lt.descript.set ease. There we go. And then for this, we will want the leantween.scale. So we may we will like grab that global variable there to define how we want the ease type to work, and then we'll go ahead and grab the leantween.scale. We want to make sure that the leantween.scale has the right input values. This one is incorrect. It looks like we need the vector 3 1, not the float value 1. So let's see how this works out here. So we will want the new scale for the vector 3 right there. See, this is not working. So let's go ahead and remove this, grab the correct one. The one that has the vector 3. There, that one looks better. So then we'll get the scale time goes into the time slot. New scale goes into the vector 3 slot. And then this dot game object will go into the game object pin. That finishes up the tile linker script, so we can go ahead and compile that, and then what we'll do is move back over to the game tiles script to add some additional functionality. Alright, once we're back in the game tile script, we are going to add an additional variable for the linker game object, what links the tiles together. So this will be of type game object, and we can call this linker geo. We'll also go ahead and create another variable called m_linked tiles. And given that we're using m underscore, this will be a property. So we'll go ahead and create a new int property called linked tiles, and we'll go ahead and right click and set add getter, and we will drag the m-linked tiles into the getter return option there, so that is set up appropriately. We also will want a new function called tile linker. So once we've named that correctly, we'll go ahead and start with an if statement, and basically we will say if the linker game object is not null or does not equal null, we're going to go ahead and do a couple different things, right? So if it's false, we'll do a debug log saying that the game linker game object is not set. If it's true, we have quite a bit of other stuff to do. So let's go ahead and add the debug.log real quick. That one's the easy one. This function is also probably one of the more complex functions that we've put together so far. So it's not extremely long, but it is a little bit more complex. You know, maybe minus the lambda function that we did earlier. All right, once we have the debug text message set up, we're going to go ahead and add two of local variables. The first one will be a game object, and we can call this one linked instance geo. It'll be a linked instance of the game object. And the next one we'll call linker, and this one will be of type tile linker. So from the true pin of the if statement, we are going to set the linked instance game object. So drag in the linked instance game object, select set value, and what we're going to do is we're going to set that value to an object.instantiate of game object of the linker game object, comma this.transform.position, and comma Quintonian.identity. So it's a little bit longer statement here, but we'll go ahead and get the object.instantiate of type game object, and we'll the original or object of that is the linker game object, and then we will get transform.position, and we will get Quintonian.identity. Right now that's set up, we're going to set the linker instance game object.transform.parent equals this.transform. So we'll need the drag in the linker, set that value, and then the linker instance game object. Alright, that one doesn't look right. We need to delete that one and grab the get component with a T or temp option. There we go, that one. And then we will select the tile linker. There, that looks a little bit better. Now we're going to go ahead and execute the tile linker.drawLink, the function from the tile linker script that we made. So go ahead and type in drawLink. You should be able to find that. There we go. And notice that it has 3 pins to fill out. This one will be linker. And then the start position will be this.transform.position, and the end position will be target tile .gameObject.transform.position. Alright, there we got the transform.position. We'll need this to plug into there, and we will want to convert this if it's an option. So convert if possible. Don't forget to grab that local linker game object and plug it into the instance or the top pin of the tile linker.drawLink. The tile linker method or function will need a input parameter called target tile. So you should add that now. Let's call that target tile, and that will be of type game object. Now we'll go ahead and use that target tile that we just created. So go ahead and right click and add node, type in target tile. That should be listed there now. And then we will get the GameObject.transform and transform.position. And then link that into the end position. There we go. Alright, we need to make a quick modification here. The mLinked tiles variable that was originally an integer, we need to change that to a list of type game objects. So change that to a list, select game objects, so that it says list of game objects. Fix that, and we'll also have to change the property to a list of game objects as well. So both of those need to be fixed. Don't forget to do that. Now we'll go back up to the top of the where the if statement is, and we're going to continue off on the finished pin. So we'll add another 2 if statements here from the finished pin, and we'll start populating those. So once that if statement is completed, these 2 if statements will go ahead and kick off. In this particular case, we're going to go if not mLinked tiles contains target tile, we'll go ahead and add the target tile. So basically, if the target tile is not in the list already, we're going to go ahead and add it. So we'll go ahead and drag in the m_link tiles. We'll connect that to the instances of the link.contains, and the item that it contains is the target tile, and then not. There we go. We'll connect all those together and rearrange that so it fits. Then if that is true, we will add the mLink tiles .list.add to the target. The target tile will be added to the list, basically. Okay, we'll drag in a list.add of game tile of typed game objects. So mLinked tiles.add target tile. So the item here is target tile. The instance is m_link tiles. Alright, the next if statement will be if not link tiles.contains target tile.gameObject. So we'll go ahead and grab in the target tile .gameObject. Then we'll need a list.contains of type linked tiles. So we'll need to go ahead and grab the linked tiles and then a list.contains. From the true pin of the if statement, it will be target tiles.getComponent of type game tiles, link tiles.add this.gameObject. So the first thing we're going to ahead and do is grab the list.add. Then we'll get the target tile, target tile.getComponent with a T there for, and we'll get game tiles. There we go. And then game tiles.linked tiles. And the object or the item here is this.gameObject. Alright, I think that wraps up the tile linker function. We'll go ahead and go over to the initialize neighbor routine, and we're going to kind of modify this a little bit. We need to add a line or two of code. So we need to add an if statement here from the body pin of the for loop, and then for the true statement, we'll go ahead and link those that we already had there. So those will stay there. We're just adding some additional logic here. In this particular case, it's mlink tiles. So we'll grab that, get, and then this will be a list.contains, which should be in the frequently grabbed list from now on, or at this point, not, and that will be into the Boolean pin of the if statement. There we go. And we will also need to feed in the value of the for loop to the list item pin. We also need the tile linker. There we go. We'll grab that and we'll put that right in the middle of the if and the previous statements that we already had. So this wraps up the initialize neighbor routine. Don't forget to add that last link from the value to the tile linker. Let's go back to the tile linker method. What we want to do is parent something. I forgot to add the parent set parent in here so that the tile linker stuff is parented underneath the tiles themselves, so it doesn't mess up our hierarchy when we push play. So what we're going to do is go ahead and grab a right click on the canvas, add node set, find the transform.parent, and squeeze it in between the set value for the linker instance game object and the set value of the linker itself. And then we will just go ahead and set that parent, the linker instance game object, transform.parent equals this.transform. I also forgot a not contains, or the not symbol here, or not option here, node here. So let's go ahead and copy the one from above, and we're going to squeeze it right in between that last if statement there. And I think that wraps up this code for now, so go ahead and push compile. Next, we're going to go ahead and actually create the linker game object itself, and this is very specific on the directions of the where the x, y, and z values are for the game object itself. So this is the game object that will actually link each tiles, center of each tiles together, and this is very specific. The directions of how this works makes all the difference in the world, because if it's not set up like this, if the blue arrow is not pointing in that direction, the green arrow up, and the red arrow to the left exactly like this, it will not work. So it took me like 5 or 6 tries to actually get this to function correctly. So make sure that you set up the game object just like this. And it doesn't have to be all that long, just maybe 1 or 2 in length. Make sure you center that that pivot point on the game object, so it's just like that. Once that's set, go ahead and create an empty game object, and then put this as a child object underneath the empty game object, and then create a prefab from this. Each of our hex and cube or tile prefabs should now have a linker game object that is unassigned. We need to go ahead and drag in the linker game object that we just created to that unassigned linker game object field. And then go ahead and save the prefabs. Also make sure that the tile linker script that we created earlier is attached to the tile linker game object top level. Once that's completed, it should run correctly. Notice that's a little bit up in the air here, so we need to modify the y-axis a little bit. This is where it's easy if it's a child object of the linker game object, is we can go into the sub object and then modify the y value. of the child object and make sure that the top level object is all zeroed out. Once we modify that, we should look a little bit better. Not too bad. It's getting better. We probably want to make that the same black color as the center object. That would make it look a little bit better. So I'll use the same material that I had before. And then I'll go ahead and update that prefab. Change the ease type to something that you might want. You can play around with that to see the look, the different looks that it has. Make sure you update that prefab, delete it from the scene, and go ahead and run it again. Our pointy hexes look pretty good. We'll go ahead and try our other flat type hexes to make sure that those also look good. That looks pretty reasonable. And then we'll go ahead and try the square, make sure we uncheck is hex, and then see what that looks like. Also notice as we hit play a few different times, it is starting at different locations. The start tile is different each time we click, so the random function that we set up is working correctly. So that really concludes our series on hex and cubes with the map generation and linking them all. Here is the final code for each of the three scripts that we created. We'll check those out so we have at least some code to go off of. Anyways, thanks, and I appreciate you attending the full all 6-part series. If you have questions, hit the Discord channel for uNode. I should be hanging out there. Thank you and have a great day. Bye.